Okay, so in this case, well, this time let's use a function pointer as a member variable. So we may move this one to here, right? Function pointer, and sometimes, well, we call we name the function pointer as a callback function. Maybe. So let's use short callback here. So let's do some test. Okay. Okay. So let's define a test, not test, geometry object maybe. Geometry object. My box and my circle, but we want different behavior of this one and this one. So let's do this one. So my box has a correct function pointer, and we want it to draw a box. Box. Oh, okay. And my circle dot callback draw circle. So we can do this. We can execute it. We can do this again. Okay, so it's working similarly to the polymorphism, right? Isn't it weird? So for polymorphism, we define virtual function. You remember the virtual function, right? Void, and we define some function like this one. And for pure virtual function, we did something like this one, right? And I told you we can use 0 instead of null PTR. So do you see some similarity? So this is what your OOP compiler does for polymorphism. They make a virtual function table to call to implement polymorphism. This is exactly what happened for polymorphism using function pointer. But in your compiler, this process, I mean this one is implemented automatically through the inheritance. Okay, that's why the function pointer is the key to understand the real OP implementation in your compiler. So if you become a really experienced OP C++ or OP programmer, you are going to use function pointers or callback functions for polymorphism. Especially if you are developing a very general software or a very maybe if you are developing a game engine, then you are going to try to determine these polymorphism properties in runtime, not compile time, so that the designers can make something and insert their content to your engine. Okay, so if you are really good at using callback functions, then you may implement polymorphism without inheritance. It's gonna be more efficient. But instead, it's gonna be more dangerous. You know, the pointers are always dangerous because of the runtime error. So it's a good thing, but on the other hand, it's always dangerous. Okay, so I talked about using function pointer as a member variable. Okay, and you may like to move these functions to here inside this class, right? Okay. So in this case, you cannot assign this function to this callback function pointer because of this one. If you want to assign this one to this one, then you need to modify this one to something like this. Okay, and you also need to modify this one to this one. So if you move the if you move these functions from the outside of this class definition to inside of this class definition, then these functions can access the member variable of this class. So maybe you can do this. You can do something like this. It's a big difference. If this function is outside of this class, then this function cannot access this variable because this function is defined outside of this class. So you cannot do this. So it's a big difference. So sometimes you want to you want to define a callback function pointer pointing to member functions. These are member functions, and this is a function pointer pointing to member functions of this class. And you could successfully assign the memory address of these member functions to this callback function pointer. Okay. So so you cannot execute in this way because this one is no longer a simple function pointer. Instead, you need to write. I don't remember exactly, but this one. This one maybe. Oh, it's not. No. I don't remember. Syntax error. I don't remember the position of this star writer. Not here. Is that right? Okay. Function pointer member function plus. Okay, it's going to work. So let's use circle for okay, let's do this. Okay, draw box, draw circle. It's working as we intended, but wrong numbers because the member variable was not initialized. So maybe, well, for clean implementation, 1, 2, 3, my box dot a, my circle dot a, 5, 6, maybe. Okay, so it's working. And well, this one doesn't look good enough. Well, we don't like to type this one forever, well, many times, repeatedly. So in many cases, we do something like this one: execute exe, and we can call this callback function inside this member variable, member function. Callback. What's wrong? So why do you think this is not compiling? This? No. This? No. Okay, let's copy and paste this one for a comparison. We did this for to execute this callback pointer outside of this class definition. So what do you think we need to do to execute this one?
Class name?
Class name? Okay, maybe. Okay, I should try. And a star maybe. Parenthesis. It's not working. What's the solution?
This?
Yep, this. I don't remember this star maybe. This. Yeah. This one. The answer is this, but I don't remember what's wrong. No.
하고 콜백 앞에다가 마스터를
여기. 됐다. Okay. It's confusing always. It's doing nothing. So this callback function is pointing to this one for example, and this function is accessing using this variable, this member variable. So this member variable should be an instance or should be a member of an instance of this class. That's why we need this here. Okay. Okay. Let's use our new function, my box dot execute my circle. What's wrong? Build. Oh. What's wrong? was the name of this project? Week. Okay. So we need to kill this one and the process. And the process. Okay, let's do this. Okay, so it's working. Here and here. It's working great, right?